All right, we're going to talk about dividing polynomials. So we're going to talk about two different types, two different ways to do that. We're going to talk about long division and synthetic division. So the first one we're going to do is long division. It works for any type of polynomial. It's pretty straightforward. And so the first one here is we have 4x squared plus 23x minus 16 divided by the quantity x plus 5. So we're going to set it up in a long division piece. Now, what we're really looking at doing is finding the first part of this binomial here. What am I going to multiply it by to get it to be the same as that number? Okay, so what am I going to multiply x by to get it to be 4x squared? So that is 4x. So I'm going to multiply x by 4x. So this gives me 4x squared plus 20x. And if you remember long division from when you're in elementary, you subtract those. So I need to make sure I subtract them. Now I will put parentheses around the whole thing, indicating that I'm subtracting that whole piece from it. So then I have 4x squared minus 4x squared, that's 0. 23x minus 20x is 3x minus 16. Okay, now I'm going to repeat that process. X times what is going to give me 3x? Well, that's positive 3. So now I go 3 times x is 3x. 3 times 5 is 15. I'm going to subtract that. 3x minus 3x is 0. Negative 16 minus 15 is negative 31. And if you remember, this is my remainder. Okay, so that's my remainder on this. And when we look at this, I could rewrite this as 4x squared plus 23 equals x plus 5 times 4x plus 3 minus 31, or plus a negative 31 if you like, which kind of brings us to this piece here, right? So it says if I have a polynomial and I divide it by b of x, I get q of x, and I get some r of x. So p of x equals the product of these two plus my remainder, okay? So we are going to kind of use that idea to check to see if it's a factor. So if it's a factor, what's going to happen is my remainder is going to be 0. Okay, so if my remainder is 0, then it is a factor. So it says, is x squared plus 1 a factor of 3x to the 4th minus 4x cubed plus 12x plus 5? Okay, so we're going to use long division. Now, one of the things that you probably should notice here is that there's missing elements, okay? So I don't have a nice power drop here. I don't go 4, 3, 2, 1, 0. I don't have a linear term in there. So I have to take that into account. So I end up with 3x, let me write this down a little bit farther. 3x to the 4th minus 4x cubed plus 12x squared plus 0x plus 5. So I want to take that into account, okay? So I want to have a placeholder there. Now, in your book, it actually puts a placeholder there also. I, a lot of times, won't. I'll just put the x squared plus 1, but I make sure that I align these with the proper power, okay? So if you struggle with that, put a placeholder in here, x squared plus 0x plus 1. It's not going to change the problem at all. So now I look at x squared times what is going to give me 3x to the 4th. Well, I need to get the 3, so I have to multiply it by 3. X squared times what gives me x to the 4th, x squared. So I'm going to write that above the x squared. So I end up with 3x squared. So 3x squared times x squared is 3x to the 4th. 3x squared times 0 is 0x cubed plus 3x squared. And I'm going to subtract that. Okay? So now my x to the 4ths cancel out. I have negative 4x cubed minus 0, which is negative 4x cubed. 12x squared minus 3x squared is 9x squared. I'm going to bring down my 0x. And I could bring down my 5 if I want. Not necessarily needed. Now, I have to see x squared times what is going to give me x, negative 4x cubed. Well, that's going to be a negative 4x. So that gives me negative 4x cubed. So negative 4x times x squared, negative 4x cubed. Negative 4x times 0 is 0x squared minus 4x. And I'm going to subtract that whole piece here. All right? Rewrite this down here so I give myself a little bit more room. All right. All right, so now I'm subtracting these. The cubes go away. I'm left with 9x squared plus 4x plus 5. Okay, so I'm going to bring my 5 down. Remember, 0 minus a negative 4 gives us a positive 4. Okay, now I'm going to go x squared times what gives me 9x squared. Well, that's 9, right? So I end up with 9x squared plus 0x plus 9. And when I subtract this, I end up with 4x minus 4. Well, I can't multiply x squared by a nice even power. I'd have to essentially divide it by x or multiply it by 1 over x to get it to be an x power. So I am done. Since this power is smaller than the dividing power, I am done. There is a remainder here, so this is not a factor. Okay? So if I get anything but 0, it is not a factor. Okay? So now the next one I'm going to do here is I'm going to do x minus 2 and x to the 5th minus 32. So I'm going to kind of put that over here. I'm going to erase this a little bit so I give myself a little bit more room. All right. So I have x minus 2, and it was x to the 5th. I'm going to write in all my 0. X to the 4th plus 0x cubed plus 0x squared plus 0x minus 32. That's a lot of extra stuff here. Okay? So now I need to, x times what is going to give me x to the 5th? Well, that's x to the 4th. Okay? So I get x to the 5th minus 2x to the 4th. It's going to be negative x to the 5th minus x to the 5th is 0. 0 minus a negative 2 gives me 2x to the 4th. I'm going to bring down my 0x cubed. X times what gives me x to the 4th? 2x cubed. So this is 2x cubed minus 2x to the 4th minus 4x cubed. I'm subtracting that. This is going to give me 4x cubed. I'm going to bring down my 0x squared. X times what gives me 4x cubed? That's 4x squared. So this is 4x cubed minus 8x squared, which gives me 8x squared. I bring down my 0, x. X times what gives me 8x squared? That's 8x. So 8x squared minus 16x. When I subtract those, I get 16x minus 32. X times what gives me 16x? Well, that's a positive 16. So I end up with 16x minus 32. When I subtract that, I get 0. Therefore, it is a factor. So x minus 2 is a factor of x to the 5th minus 32. Okay? So x minus 2 is a factor of x to the 5th minus 32. Okay? Now, I'm going to bring us into synthetic division here. Erase this, give us a little bit more room here. Synthetic division is really nice when we're talking about linear binomials. and especially linear binomials where it's x plus a number or x minus a number, okay? So in synthetic division, the first thing we're going to do is write down my coefficients. So I'm going to write down all these coefficients. So I have 1, minus 14, 51, negative 54, okay? And the next piece is I need to look at what value is going to make this 0, okay? So that's going to be negative 2, okay? So it's important that you understand you have to be able to find what value makes that 0. That's going to go into this reverse L here, or this side box, okay? Now, when we're doing synthetic division, our first coefficient is going to come straight down. So this becomes negative 1. Or sorry, just becomes 1, okay? Now, what I'm going to do is I'm going to multiply 1 by negative 2. So negative 2 times 1 is negative 2. And now I'm going to add those together. So that gives me negative 16. Now I go negative 2 times negative 16 gives me 32. I add these together. I get 83. I'm now going to multiply negative 2 times 83 is negative 166. I add these together and I get negative 220. Now, the good thing is I know this looks like these numbers don't mean anything. But what this is these are now the coefficients, and this is my remainder. Okay? So now I go 1 power less, so this becomes x squared minus 16x plus 83 plus negative 220 over x plus 2. Okay? Or I could rewrite it like this. X plus 2 times x squared minus 16x plus 83 minus 220. Okay? So these new numbers are my coefficients on my dividing piece. So up here, it's these values. Okay? So the nice thing is synthetic is pretty quick. Most of the time we can do this in our head, because it is just multiplying and adding, multiply and add, multiply and add, and you're just dealing with single numbers, okay? So what makes this 0? That's going to be a 7, so that goes back. And just like in line division, if we're missing a value here, we have to have a placeholder. Very, very, very important that you have a placeholder. So this becomes 1x cubed. Well, how many x squareds do I have? I have 0. And then I have negative 57, and then I have 56. First value drops straight down, 1. All right? All right, 7 times 1 is 7. 0 plus 7 is 7. 7 times 7 is 49. Negative 57 plus 49 is negative 8. 7 times negative 8 is negative 56, and that gives me 0. If that remainder is 0, remember that this is a factor. So now my new, when I divide that out, that's going to equal x squared plus 7x minus 8. All right? So synthetic division can be very, very quick, especially if we have a nice binomial here, okay? X plus or minus some constant. If it's 3x plus 2, you have to understand that what's going to go in here is going to be a fraction. Okay, so you're going to deal with a fraction. Which this brings us to our remainder theorem. So the remainder theorem states that if you divide a polynomial p of x of degree greater than or equal to 1, so 1, 2, 3, 4, 5, by x minus a. Okay, that's what we've been doing here. Then the remainder is p of a. So whatever I get down here is the same as if I plugged in negative 7. Okay, so I got a 0 here. So on this one, if I plug negative 7 in here, negative 7 cubed minus 57 times negative 7 plus 56. Okay, so this gives me negative 243. 57 times 7 is 399. Oh, 343, sorry. 343 plus 56. Okay. Something's off. I rewrote that wrong. Oh, it's supposed to be positive 7. Okay. So there we have, so this ends up being negative 343 minus 399 plus 56 is 0. It's the same thing we have there. So it's always when we're plugging this in, that's our remainder. So it makes it nice because what happens is when we get into really large polynomials, we can use synthetic division fairly quickly to find that value. So here's an example of p of x equals x to the 5th minus 2x cubed minus x squared plus 2, and you want to plug in 3 to it. Okay? Well, the tough thing is we're probably, if we want to do this, yes, we could take a calculator, plug it in, go 3 to the 5th, find out what 3 to the 5th is, minus 2 times 3 cubed, minus 3 squared, plus 2. We could absolutely do that. Wouldn't take us a huge amount of time, but we could also go like this. 3, 1, 0, negative 2, negative 1, 0, 2, and simply multiply and add. 3 times 1 is 3. That gives me 3. 3 times 3 is 9. That gives me 7. 21, 20, 60, 60, 120. 2 plus 120 is 122. There's my answer. So P of 3 equals 122. And so it makes it very, very easy because I don't have to try and do that in my head. Like here, most of us would probably have to have a calculator. We might be able to get it in our head, but it's going to be piece by piece, right? You're going to kind of go here and go, oh, okay, well, that's 243. This is 27 times 2, so that's negative 54, minus 9 plus 2, and then add them all together. So synthetic division helps us. The key to synthetic or long division is making sure you have those placeholders. Okay, it's very, very important.